Today we're going to learn how to do the change of base. And so we're going to use this formula right here. And we're going to change the base of log base 5 of 16. And we have to change the base for the common log, or log base 10, and the natural log. So we're going to start with the common log.
I have a question, teacher.
What's your question?
What is the natural log?
No questions. Alright, so we have the log base 5 of 16, and to change the base. So the x is going to be 16. So we do our new base, which is common log. It's going to be log of 16 over log of 5. And so that's how we change the base to the common log. And then for the natural log, it's going to be
so much
pretty much
sense
the same
now.
thing. So
I understand it so much better.
So we get log base 5, 16, and that's going to equal, if you just substitute the logs in this one for the natural log. So it's going to be natural log of 16 over natural log of 5.
Oh.
There we go. Alright, today we're going to be solving for x, and there's 3 decimals of this 8-part function. It's 1,000 e to the negative 4x equals 75. So straight off the bat, easy money, divide by 1,000. So we get e to the negative 4x equals 75 over 1,000. And then after that, we're going to take the natural log of each one. And then these are going to cancel out. And then we get negative 4x equals the natural log of 75 over 1,000. And then you divide all of that by negative 4. So you get x equals the natural log 75 over 1,000. And then that whole thing over negative 4. Alright, once you plug that into our calculator right here, we get 0.648. That's your answer right there.
Alright, class. Today I'm going to teach you how to graph logarithmic functions. So we got 4 to the x minus 3 plus 3. Now the first thing we're going to do here is identify the parent function, which happens to be 4 to the x. So I'm just going to write that right here. And now I'm going to make an xy chart and plot points that would be on this graph. So we're going to go with 0, 1. Just check quick. You can crop this out. Oh, my apologies.
Apology not accepted.
Worst teacher ever.
Alright, we're going to go with -1, 0, and 1 for our points. When we plug that in, we get 1/4 for -1, 1 for 0, and 4 for 1. Alright, migrate over here to my lovely graph drawn by yours truly. Alright, so -1, 1/4, right here. Then we got 0, 1, so it'll be about right yonder. Don't know why I put it right there, it's actually going to be right here.
Messed up your other one too.
And then we got 1, 4. Right? Okay. Alright. So, now, we're going to look at the original problem and identify what the differences are. So, we got a minus 3 right here, which actually is adding 3 to the x coordinates. So we're gonna add 3 to the x's right here, and then right here, this is a change on the y, so we're gonna add 3 to the original y. So we're gonna add 3 to the y right there. Okay, so now we gotta make a new xy chart for 4x minus 3 plus 3. So our first point, if we add 3 to x, is going to be 2, then 3, then 4. And over here, we're going to have 3 and a fourth, 4, and 7. So these are going to be our points for the translation of the parent graph. So we're going to go over here and plot these points. So as you can see here, we have the original. I'm going to erase that. We're going to draw the new one. Alright? So we have 2, 3 and a fourth. So 2, then 3 and a fourth. It's about right there. And then we got 3 and 4. So 3 and 1, 2, 4. About right here. And lastly, we have 4 and 7. So 4, 7. Alright. Now if you go back in the video, you can see that this is practically the same graph that we had originally, except it just got shifted up 3 to the right 3. And that is how you graph, ladies and gentlemen. Okay, class, today I'm going to teach you about compound interest. Now, we got a word problem here today. Let me read it to you. On the day of a child's birth, a parent deposits $30,000 in a trust fund that pays 5% interest, compounded continuously. Determine the balance in this account on the child's 25th birthday. All right, so now we got a key word in this problem that shows us it's going to be compound interest, and that is compounded continuously. Now the formula for compound interest is A equals P E to the RT. Now let me explain to you what these letters mean. We got a hodgepodge of letters up here. I'm going to explain to you what they mean right now. All right, so let's start with P. P is the initial amount. Then we got A. Or no, you know what? Let's go up to R and T. So E is actually a number that is going to be used. It's in your calculator. You can just plug it into your calculator. R is the rate at which it's invested. So, for example, in our problem, it's 5%. So we're going to plug that in as 0.05. And T here, that's how long. That's the time. So in years. So now let's write this out with numbers. All right. So first, let's just write. Okay. So, oh yeah, an A, that's the amount after a certain amount of years. So that's what we get in the end. So we're gonna write this equation out as 30,000 times E to the 0.05 because 5 was 5% interest, so that becomes 0.05 if we write it as a decimal, and then time is 25 years. I'm gonna put 25 right here for T, and now we gotta solve for A here. So plug this into our calculators, and when we plug that into our calculator, we get 104,710 and 29 cents. And that's your answer, ladies and gentlemen. You're gonna put a little dollar sign. That's our end answer. Thanks for watching.
Okay, so I'm going to be showing you how to do a word problem from section 3.5, and I'm going to be doing
number 33, so pause if you want to see that. But I'm going to get right into it. So we're going to use the APERT formula for this. So A equals P e to the RT. I'm going to first plug in 400 equals P e5R, and then 100 equals P e3R under it, and we can simplify from there. So it then becomes 4 equals E2R, and then, so that's what we have so far. And then we can do the ln of both sides since it is E. So we get ln of 4 equals 2R, and we're going to bring the 2 over. So it then becomes 1/2 ln of 4 equals R. So then we have R. So we're going to plug R into the first equation. So 100 equals P e the 1/2 ln of 4, and then we're going to use 3 because that's how many years for 100, and then we get 12.5 equals P, so we have found P, and we're finally going to plug P into the equation. So A equals 12.5 e to the 1/2 ln of 4, and we're looking for the amount of bacteria after 6 years, and then we get A equals 800 bacteria. And that is your final answer. So if you see the work right there, so there's the first part, and then we get that. And that's it.